The important thing is not to stop questioning. Albert Einstein. Watch until the end. The structural detail in the final section changes the definition of vision. Hypnops Agassizii is an abyssal fish inhabiting depths between 2,000 and 6,000 meters. It belongs to the family Hypnopidae and is closely related to tripod fishes, though its most striking feature is located on its head. At first glance, it appears eyeless. Instead of conventional paired eyes, Hypnops Agassizii possesses a flattened, translucent cephalic plate covering the dorsal surface of the head. Beneath this plate lies a modified light-sensitive structure. This is not absence, it is reconfiguration. In total darkness, image-forming vision becomes nearly useless. However, detecting faint diffuse bioluminescence from above can still provide ecological information. The dorsal plate acts as a broad photoreceptive surface, optimized not for forming images but for sensing intensity gradients. The body is elongated and lightly built. Pigmentation is minimal, often pale. Fins are modest, adapted for slow, energy-efficient hovering above the seabed. Like other abyssal species, buoyancy management relies heavily on tissue composition rather than gas-filled swim bladders, which are inefficient under extreme hydrostatic pressure. Midway through this analysis, recall Darwin's adaptive principle. It is not the strongest of the species that survives, nor the most intelligent but the one most responsive to change. Charles Darwin. Hypnops Agassizii did not improve its eyes. It replaced the concept. Here is the overlooked detail. The cephalic light-sensitive plate increases surface area compared to traditional eye structures. While resolution is sacrificed, total photon capture probability rises. In environments where photon availability approaches zero, maximizing capture area outweighs visual clarity. This suggests a shift from directional vision to ambient detection. Its feeding behavior is benthopelagic and opportunistic. It consumes small crustaceans and invertebrates encountered near the abyssal floor. Movement is minimal. Energy conservation dominates. The skeletal system is moderately ossified but not heavily calcified. Tissue density approximates seawater density, reducing locomotion cost. What makes Hypnops Agassizii exceptional is conceptual. It demonstrates that vision is not synonymous with eyes. Sensory function can detach from classical organ structure. In the abyss, definition bends. The dorsal orientation of the photoreceptive plate implies detection of silhouettes or faint luminescent patterns descending from above. Even minimal contrast can signal food particles or predators. This is not blindness, it is environmental specialization. If this breakdown redefined your understanding of sensory evolution in extreme ecosystems, support the channel. Subscribe for precise, research-driven deep-sea analyses like this video to expand scientific reach, and comment which abyssal species should be examined next. Engagement directly sustains structured marine biology content.